Namaskaram. Welcome back to my channel, Chemistry in a Nutshell. We'll continue with the discussion on solid state. And today I'm going to discuss about a very unique type of unit cell called hexagonal unit cell. Now you have already seen, according to the different arrangement of atoms, you have already seen there are 4 categories of unit cell. Now this one is slightly different compared to the unit cells which you have learned in the prior videos. So here we are going to discuss only about the hexagonal unit cell. Now we are going to study about the way the atoms are arranged in this hexagonal unit cell. So before getting into anything, first of all, let me draw a hexagonal unit. So before doing anything, let me draw the hexagonal unit cell, and then slowly I'll explain how is the arrangement of the atoms and what is the total number of atoms present in such unit cell, that is hexagonal unit cell. So before getting deeper into hexagonal unit cell, what we are going to do is, first of all, I am going to draw the hexagonal unit cell. So here you see, I'll draw a hexagon first. I'm trying to draw it in 3D. And please remember that it's a regular hexagon, so each angle will be 120 degree. I'm trying to draw it in 3 dimension, hence you will find that the angles are not very accurate. And of course, it's freehand drawing. So here we have the hexagon and the back ends I'm drawing. Let me draw that using dotted lines. This is at the back end of the hexagon. This is the front end. So we have a hexagon over here. And let me draw the atoms over here. Each of this, like I had already mentioned this in the previous class, each of these dots which I'm drawing at the corners are basically the particles or atoms in this case. So here we have atoms out here, you can see at the corners. So we have 6 atoms at the top, and here we have 6 dots or 6 atoms at the bottom. So first of all, we'll try to understand this, the number of atoms at the corners. At the corners, how many atoms are there? There are 6 at the top end and 6 at the bottom end. So we have 12. So 12 atoms are present in the different corners. Now, what part of the atom is inside this hexagonal unit cell? We have to understand this. Now, let me tell you something, that this dot is not the atom but the entire structure, the entire sphere. It's like a ball. You can imagine the atom to be in the form of a sphere or a ball, and you see only partially a portion of this particular sphere is inserted into the hexagonal unit cell. So we are going to see, or we are going to find out, what part of the atom, the spherical atom, is inside the hexagonal unit cell. So it's very simple. What I'm going to do is I'm going to expand this, and at least I can see the lower half. The upper half is simply cut off. The lower half, you can imagine this is the lower half. I'm just drawing the cross section of this sphere. So in a very magnified way I'm drawing this, and you can imagine this is to be the center point, and this line is this, and this is the line out here. So somewhat like that. So the question arises, so that means this particular portion is inserted into the hexagonal unit cell. Now the question arises, what part? If I want to, quantitatively express this, what part? Now we know that each angle of a hexagon is 120 degree. I already mentioned before that it's you can consider it to be a regular hexagon. So it's 120 degree. So if it is 120 degree, this particular angle is 120 degree. And the entire circle is obviously 360 degree. So 120 divided by 360, we get 1 by 3. So 120 divided by 360, we get 1/3. Now this 1/3 is only for the lower half. That is for the semisphere, the semicircle. Only for this half of the sphere, it's 1/3. If you consider the entire sphere, this will become 1/6. If you consider the entire sphere, it will become definitely 1/6 because half the sphere is 1/3. So we had 12 corners, and then we have what portion of the entire sphere is inserted into the hexagonal unit cell? That is 1/6. So 6 2 is 12, so we get 2 atoms at the corners. So there are 2 atoms basically. Now I already mentioned that it's a very special type of unit cell. So here we have 3 atoms which are inserted inside the body of the hexagonal unit cell. So you can imagine there are, let me draw it a bit bigger for you to understand. There are 3 atoms which are kept inside the body of the unit cell. So there are 3 more. So inside the body, the entire atom is being inserted. So we have 3, and since the entire thing is there, so 3 into 1, we have 3. Now since this is unique, there is one more situation where we'll have an atom at the 2 end, an ended system. So we'll have at the top end as well as at the bottom end. So if that is the case, we know that half of the entire spherical atom is inserted out here. So we have 2, so this is at the end, 2, and half of the spherical atom is inserted into the hexagonal unit cell. So we have 1. So total, how many atoms are there altogether? 6. So 2 atoms at the corner, 3 atoms at the body, inside the body, and at the 2 ends, we have 2 into half because half the portion of the spherical atom has been inserted, so we get 1. So total, we have 6 atoms for the hexagonal unit cell. Isn't it easy? Now, what we are going to do is, I'm going to jot down this in the form of a table for us to easily understand. So now, what I'm going to do is, I'm going to make a consolidated table where I'm going to write the number of atoms present in each of the unit cell. Now, why am I doing this? This is because we are trying to make a consolidated sheet where we'll know the total number of atoms present in each of the unit cell. This is the reason which you have to learn by heart. In fact, it doesn't matter. It is too easy. You have seen this, but several questions come with respect to this. So we are going to first learn how to make a consolidated table referring to the total number of atoms present in each of this unit cell. So this is a way of categorizing the types of unit cell according to the number of atoms present in each of the unit cell. So let me write the heading: types of unit cell according to the number of atoms present in each unit cell. So, we are going to learn how to categorize the number of unit cell according to the number of atoms which are present in each of the unit cell. Now let me make a table unit cell, atom arrangement, a bit of a revision, you can imagine it to be. And here I'm going to write the total number of atoms per unit cell. This is also called rank of unit cell. This is also called the rank of the unit cell. So we are going to learn or find out the rank of the unit cell. So we'll begin the first one, which you have already learned it in the video prior to this. So we had the simple unit cell or primitive unit cell. Remember, when I talk about the simple unit cell, we have atoms at the corners only. So we have corners. How many corners were there? There were total 8 corners, and 1/8 part of a spherical atom was inserted in each of this corner. So we got 1, isn't it? 8 cancel, so we get 1. So the total rank of this type of unit cell, that is simple unit cell, is 1. Next comes face centered. Remember face centered? So here we have the corners as usual. Along with that, we have the faces. So how many atoms were there in the corners? As usual, the same way, 8 into 1/8, that is 1. And in the face, how many faces were there? Remember, there were 6 faces, and each of the face had half of the portion of the spherical atom inserted. So 6 into half, that is 3. So we got total 4. So the rank of this type of unit cell is considered to be 4. Next comes body centered. So here again we have the corners as usual. So this particular the corners are always present in each of the unit cell. So 8 corners, this is 1, and inside the body we had 1 entire sphere, so 1 into 1 we have 1, so it comes to 2. So therefore the rank of this type of unit cell is 2. And then we have end centered unit cell. So we have corners, we have 8 corners, and 1/8 part of each of the corner, each of the spherical atom is inserted. So we have 1, and at the ends there were 2 ends. You have to take 2 opposite ends, I believe you remember. 2 ends, and remember, half the portion of the spherical atom is inserted into it. So we get 1. So total we have 2. So therefore the rank is 2. And of course the special unit cell which we have just learned, that is hexagonal unit cell. In hexagonal, this was really special. We had several options over here. We had corners, and remember how many corners were there in the hexagon? 6 at the top, 6 at the bottom, so we have 12, and 1/6 part of it is inserted, so we have 2 out here. Then we have inside the body we had 3 entire atom inserted, so we have 3 atoms over here. Then at the face, the 2 opposite facing places where half of the spherical atom is inserted. So 2 into half, we get 1. So total we have 6. So here we have the rank of this kind of unit cell, that is hexagonal unit cell, is 6. So now we are going to learn about different types of cell according to cell parameters. I'll just write that. Types of cells according to cell parameters. Now what are these cell parameters? We have to understand this. Basically, the number of categories according to cell parameters is 7. I'll talk about this later. But first of all, we have to understand what are the cell parameters. Remember, I had drawn the cubic unit cell. And cubic unit cell, I believe you remember that it's in the form of a cube. That is, the length, breadth and height all are equal. I believe you know this. A cube, a simple cube. So here, I'm going to draw a cube once again to understand the concept of the different cell parameters. So let me draw a cube or a cuboid. You can draw anything, it doesn't matter. The concept should be clear. Simple. A three-dimensional diagram. So here we have a cube, and let this particular distance from here to here, the distance be A. So this particular distance is considered A, and the angle which is opposite to this will consider it to be alpha. So these are two parameters. So you can imagine this to be, if you think it graphically, this is basically the z-axis, this is the x-axis, this is the y-axis. What we are trying to draw out here is a figure in 3 dimensions. So here I have taken the distance to be A and the angle opposite to it to be alpha. For this, inside x-axis, let this particular distance from here to here, the distance be B. And the angle which is opposite to this line, we'll take it as beta. Similarly, this particular distance, that is from here to here, that is this particular distance, we'll take it as C. And the angle which is opposite to it, which is the angle which is opposite to it? This is the angle, we'll take it as gamma. So, we have this different parameters. So, what are the different parameters? Alpha, beta, gamma. This alpha, beta, gamma are called axial angles. Alpha, beta, gamma are called axial because they are on the axis. Axial angles. And A, B and C are called axial length. That is the length which is on the axis. So these are the different cell parameters. So depending upon the value inside this axial angles and axial length, we categorize unit cells according to 7 different types. So there are 7 types of unit cells according to cell parameters. Now we are going to learn this. The first one. The first one is cubic. Let me write down the unit cells first, the 7. Then it's easier for me to explain you what are the contents or what are the values of the cell parameters. So first of all, we have cubic unit cell. Then we have tetragonal unit cell. Then we have tetragonal unit cell. Next, we have orthorhombic unit cell. Then we have monoclinic unit cell. Weird names. Then we have triclinic unit cell. Then we have hexagonal unit cell. This we have just learned. And finally, we have rhombohedral unit cell. Now we are going to see the different cell parameters. So for cubic unit cell, So for cubic unit cell, let me draw a line this way for us to easily distinguish. Now the cell parameters for unit cell. Here the value of alpha, that is the axial angle, alpha, beta and gamma all are 90 degree. They are equal to each other. Along with that, they are all 90 degree. And the axial lengths, that is A is equal to B and B is equal to C. That means all the axial lengths are same. It's obvious because it's a cubic unit cell. Cube, the length, breadth and height, of course. You can imagine this to be length, this to be breadth, this to be height, all has to be equal and hence it's a cube. And the angles are obviously 90 degree. Now when it comes to tetragonal unit cell, what do we have? In a tetragonal unit cell, we'll have the axial angles, that is A is equal to B, however B is not equal to C. However, the angles are still the same, that is alpha is equal to beta equals to gamma is equals to 90 degree. So here we find that two sides, that is two axial lengths are equal, the third one is not matching. However, the angles are still 90 degree. Now we'll go for orthorhombic unit cell. In orthorhombic unit cell, all these angles are still 90 degree. However, when it comes to the axial lengths, they are all not equal to each other. So alpha equals to beta equals to gamma equals to 90 degree. However, A is not equal to B and B is not equal to C. Now, monoclinic unit cell. In monoclinic unit cell, what do we have? Alpha is equal to gamma, which happens to be 90 degree. However, when it comes to angle beta, it is not equal to 90 degree. And the axial lengths are all different as usual, just like the previous unit cell, not equal to each other. Next we have triclinic unit cell. In triclinic unit cell, it's highly unsymmetric. Nothing is equal. That is, alpha is not equal to beta and beta is not equal to gamma and they are not equal to 90 degree, and even the axial lengths, that is A is not equal to B and B is not equal to C. You see, at least over here we had two angles which were same. Here nothing is same. So it's total unsymmetric. The hexagonal unit cell, we have learned this just now. So here what happens is alpha and beta are 90 degree, no doubt regarding it. However, when it comes to gamma, this is 120 degree. I already mentioned this before, since it's a hexagon. So gamma, this one will be 120 degree. And A is equal to B and B is not equal to C, because the height may vary. The top and the bottom end will be equal. A and B are same. However, when it comes to the height, this may not be same. So it is not equal to C. A is equal to B. So two axial lengths are same over here. Finally, in rhombohedral unit cell, what do we have? We have the angles which are not, they are equal. Alpha, beta and gamma, they are equal, but they are not equal to 90 degree. And the axial lengths are same. Now you see, there are 7 different categories. 7 different categories of unit cells according to the cell parameters. And there, prior to this, we had learned the number of unit cell according to the total number of atoms present in it. Now, each of this unit cell, that is the unit cells which you have learned according to the cell parameters, can be of those 4 unit cells which I have talked about. That is, when it comes to cubic unit cell, it could have been a simple unit cell, or it could have been face-centered unit cell, or it could have been body-centered unit cell, or it could have been end-centered unit cell. So each of this unit cell can be of those 4 different unit cells depending upon the arrangement of the atoms. So each of these unit cells, which is categorized according to cell parameters, can be invariably changing according to the total number of atoms, the arrangement of atoms present in it. So since each category can be of 4 different types, there were 7 categories. So 4 into 7, we get 28 different categories. So there is a possibility of having 28 different types of lattices. However, it has been seen, of course, experimentally, that there are only 14 variants, you can imagine. And this 14 variants are called Bravais lattice. And these 14 variants are called Bravais lattice. So these are called. So let's start with this. We are going to see what are the different possibilities or what are the different type of arrangement we have for each of this unit cell. So for cubic unit cell, we have 3 different variants. And what were the 3 different variants we have? We have simple, or the primitive one, that is at the 4 corners, remember? And then we have the face, that is all the 6 sides. And then we may have the body unit cell. So there are 3 possibilities of arrangement of atoms inside the cubic unit cell. Now when it comes to tetragonal unit cell, there are only 2 possibilities. What are the 2 possibilities? That is, it may be either simple or body centered. When it comes to orthorhombic unit cell, for orthorhombic unit cell, this has the maximum arrangement. In fact, all 4 unit cells which we have learned according to the number of atoms or the arrangement of atoms in it, all 4 possibilities are possible in an orthorhombic unit cell. That is, 4, we may have simple, we may have face centered, we may have body centered, we may have end centered. So all 4 possibilities. This has the maximum varieties or variants. Orthorhombic unit cell. Next comes for monoclinic unit cell, there are only 2 possibilities. That is simple and end centered. Okay, now for the triclinic unit cell, you have only 1 possibility, that is simple. For hexagonal unit cell, this is a special one. It had, remember, the mixed category. It's neither simple nor face or, either of these 4 categories which we have learned. It's mixed form. So, and there is only 1 possibility, the mixed possibility. And for rhombohedral unit cell, even this one is 1. And this is simple. Remember, hexagonal unit cell can be taken in either of the 2 categories. That is, we have learned prior to this, we had learned the types of unit cell according to the rank, that is the arrangement of atoms inside the unit cell. So if you take 5 out there, here it will come up to 6. And if we take 4 over here, we have to include the hexagonal unit cell over here, which is usually the practice. So we have 7 out here. Anyway, getting back to this, the Bravais lattice. So here, how many possibilities or arrangement we got, or the different number of variants we got for this? 3, 2, 5, 5, 4, 9, 10, 11, 12, 13, 14. So we have 14 variants. These are called Bravais lattice. So there are 14 different possibilities of getting, lattices or unit cells with respect to unit cells categorized according to cell parameters. Hope you understood it, liked it, and please keep a note of it. Thank you. Namaskar.